Hello coders, in this video we will see next question of our binary tree DFS list, which is from LeetCode 75 list, and let's see what the question. This is a really classic question. Yeah, now this is. I have been asked this question in one of interview and I have solved this question in one of OA online assessment. So yeah, this is important question and you need to understand what does this question says and what the pattern it have. Okay, so let's see what the question is. Question is lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor of two given nodes in a tree. Okay, we have given two nodes, we need to find their common ancestor and that should be lowest. Okay, what does mean lowest here? The highest you can take it as highest is root. That's root is everyone's ancestor. Then there will be the left node, there will be the right node, and if PQ at the left side only, then the left side node will be the ancestor also. Then we don't consider the right side nodes. Right side node we will not consider calls. The both node will as at they are at the left side. We will check left side and we'll check it. So okay, highest common ancestor is root. Lowest common ancestor. Then what is the lowest common ancestor? Let's take a path from root node. Okay, they have given the definition. So let's read first their definition. That here they have given the definition. The lowest common ancestor is defined between two nodes P and Q as the lowest node in P that has both P and Q as descendant, where we allow a node to be descendant of itself. Do you understood this? If you don't, I'll understood this. Like I'll tell you this. What does this say or what does it actually mean? We have a P node, we have Q node, we have a path from root node to the P node, we have a path from root node to the Q node, and then as both paths will start from root node, we will start comparing common nodes. Like root will be common, right? The if and the next we will see if there is something which is common between them in next path also. Like root is common and then also something is common. Let's take we have a P node and path from root to P node is, let's say we have A, B, C, D and P. Okay, and path from root to Q node is A, B, C, E, Q. Okay, here if I compare, or we can say A, B, C, Q. Okay, and whatever you say is there, there will be the path and there ABCD means nodes. There will we will arrange this nodes like this, and for Q we will arrange like this, and we will check A. Okay, it is common. BB. Okay, it is common. CC. It is common. QD. No, it is not common. So what was the last common one? C. So this C is the common ancestor for P and Q. Okay, so this you understood in case of like I took this as string format, but let's take example of like first example. What they have said 5 and 1. Okay, we have P is equals to 5 and Q is equals to 1. What are the path for P? Path for P is equals to 3 from root. I'm saying 3 and 5. And the same thing path for Q is 3 and 1. So who is the common one here? 3, and then we don't have any commons, so answer will be the 3. Okay, they have given 3 answer. Then we have 5 and 4. Okay, we'll take this, and the P node is 5, Q node is 4, and the tree is the example number 2. And for P is equals to 5, we have the same path, that is 3, 5, and for Q is equals to 4, we have 3, 5, 2, 4. This is the path, right? And then we will check, okay, 3 common, 5 common, then I don't have any node. So it means the last common was 5, the answer will be 5. Answer is 5. So now you understood what does common ancestor means. So for every time do I need to check, like we need to take a path list of for both node, and I need to check do have the common nodes and the last common node I need to return. I can do that, but it will take like see now, as we are storing the path, so it will take space, right? It will take big of n space for above question, like for above uh, strategy, not strategy, the for above approach, it will take big of n space as we are storing the path for both the big of n, big of n, big of n only. Time velocity will be big of n only cause as we are visiting every node. And here, can we reduce this? Yes, we can reduce this, as we can do DFS traversal and we can reduce this. So how I am saying like fully confidently ki yes I can reduce this. So what I think ki, how I can do this ki I have node, and then what I can do ki if I like how many cases are there, let's see, and then we will see ki yes we can do this in less space. I have a root node. If my root node is equals to null, then let write code and then we will see. If my root is null, then can I go further to find P and Q? No, right? So I have to return null. Okay, and what if my root P is null and my root Q is null? If my P equals to null, then what will be the answer? As my P itself null, then, and I don't know about the Q. Whatever the Q is, from that queue we can go to the leaf node, and after that leaf node we have like leaf node have the child nodes, null child nodes, right? Like it's there are no child nodes as they are leaf nodes, and one of them can be P. So Q node itself will be the lowest common ancestor for P and Q. You understood this? If any of node is null, then we will return the other node, return Q. Now you will ask me, what if both are null? Both are null, then return null only cause then there is no answer, right? That's why we need to check if P is null, then we will return Q. If my Q is null, then we will return P. Okay. Now, okay. Now, what if my root node is P and my root node is P, like let's say I have an example, let's take here. I have P is equals to 5 and I have a Q equals to 8. In that case, as I'm doing the recursion, I'll find those nodes, like what I will do I'll do the same procedure to the left, to the right, then again I will do the same procedure to the left, to the right. Likewise I will go till what point I can go till doing this, till my root node should like root node, if my root node uh, goes to the null, like root node is now null, then I can't proceed further. What if my root, what if I like okay 1 minute, I need to check this first, right? If, then I'll go and then I'll check root. Now we will check it. If my root is null, then I can't go further. What if my root node is P? Root node is P, then what? I am at P, then there is a guarantee that I'm saying as we took this example 5, and what if I say I'll go first left and I'll find, then my roots left, I go to the root left and it is a 5, so that 5 is equal to the root only, like as the root shifted to the 5 and P itself a 5, now both are equal. As both are equal, then I can say yeah, I can say as I found one node now, then I can found a second node further, so I can return the P node. For now I am returning my P node cause I found the P, and I right now for me it is like further I can find Q. in this tree. So I'll return q. What if my root node equals to q? Then what I will say ki, okay, I found the q, then further I can return p. Like further, if I found p, then I can return p, and if I found q, I should return q. Why? If I found p, I can say ki I can find q further, and now I will return p. And if I found q, then I can say ki I can find p further. Right now I found q, and this is the common ancestor only. Because if I go ahead, then it's basically like ki we are going to the node's child, right? And we can't go to the ancestor now. Like we can go to the ancestor, but what I'm saying is, if p is root and we want p's ancestor or p, and I'm going to the child node, does the child node can be the ancestor of p node? No, right? So my if my root node is at p, so I have to return p, cause further I'll go to the child, as my findings are going to the child nodes. The child node can't be my ancestor. That p will say ki I found first, and now you are finding to the next my child. So there is no point to find further, as child nodes can't be my ancestors. So I'm returning p. Like I found it. I found root node is p, so I'm returning p. Likewise, root node, if a root node is q, I am returning q. Okay. Now we will do the same thing for the left, like for the left side. I will say ki my tree node. I'll take this tree node. My left find is equals to lowest common ancestor for root. I'll check the same thing for the left side, and this for the right, and the same thing for the right side. We need to find lowest common ancestor for both the nodes. So we have to do, now we have two options only, that left side and right side. So we'll go to the left, to the right. Now in one of it or both of it can be not null. That permutation combination we will do here right now. What if my left find is equals to null? If my left find is null, is equals to null, that I don't find any of node at left side. So so I can say okay, then you must be found the lowest common ancestor at right side, as there is no, as I don't have answer at left side, then it must be at right side. And what if my right find equals to null, then I can say it must be at left. Then as I right will say as I am null means I don't have any answer. Then the left find, whatever the left finds answer, uh, return that. Then what if you both have the answers? Likewise, like here I said p and q. Here let's take this example, like 6, like p is equals to 6, and okay, what we will do, we will take 5 only, and we will take q is equals to 1. Simple example. When I'll go 5 isn't null, 1 isn't null, root isn't null. Root is equals to p? No. Root is equals to q? No. Left find, go to the left, and root left is 5. I am at 5, and my p is 5, and q is 1. Okay, I am here again, and now I will see ki, okay, p is null, no. Q is null, no. Then I will say ki, okay, root is 5 and p is also 5. So return p. So my left find will be p, and likewise I'll return the p here, and when I'll go right side, I'll check it, and I can find the one. I'll go right side, then root node is 1, p is 5, q is 1, and this p isn't null, so p equal to null, no. Q is equal to null, root is null, no. Root is equals to p, that right now root is equals to 1. So 1 is not equal to 5, but 1 is equal to 1, right? So q is 1, return q, that is q means what here? 1 only, return q. And the left find is 5, right find is 1. So as I found nodes on both sides, that means ki the one on which I am it is the common only, because on both sides I have found nodes. So I will return the root only. So let's run this and submit it. It is accepted. And what will be the time complexity for this? As we are visiting every node, the time complexity for this will be big of n. And what will be the space complexity now? You can tell me what will be the space complexity? For now, the space complexity will be big of h. Big of h means what? As I am taking this internally, it is I'm solving this question using recursion. Internally, it use stack. On stack, how many calls will be there? How many number of calls is equals to height of the tree. So big of h. Okay. So that's it for guys, and we will see in next video. Till then, bye bye.